Welcome back to Leaders Whiteboard. Uh, in the last session, episode 12, we talked about understanding SDLC. We talked about agile delivery methodology, lean principles, waterfall model, and so on. So today, I want to talk about the team structure. So as an engineering leader, you have to often give input to or design multiple teams within an organization. And how do you design it? Or how do you give feedback on these or restructure it, reorganize it? So there are many ways you can do it. There are a few theoretical models that are there. So today I want to focus on two of those models and maybe mention a few others just as a passing remark. Those two models are Spotify model and team topologies. Conway's law comes into picture anytime you want to talk about structuring an organization in multiple departments and teams. So Melvin Conway first came up with this Conway's law in 1967. What it tells verbatim is this: like any organization that designs a system defined broadly will produce a design whose structure is a copy of the organization's communication structure. So basically, the structure of your team, the structure of your software or the system that you create, it will mirror that. That's the main idea. Conway's law emphasizes the need for crucial consideration of how teams are structured and how they communicate, because these factors will inevitably influence the design and functionality of the systems they build. It underlines the importance of aligning organizational structure with the desired architecture of the system being developed. So let's see a diagram to understand what it means that the team structure will define the software structure. Well, how does that work? Yeah. In first example, if you look at the diagram, you'll see here is a small organization with small distributed teams, an organization with small distributed teams. You will see the system that they develop are more likely to produce modular service-oriented architecture. Each team is trying to handle their own module. So the system structure is reflecting what's the team structure. That's the whole idea of Conway's law. Or let's take another example. Let's say there is in an organization, there is a large co-located teams, not small distributed teams, but a large team co-located with each other. And they are more likely to produce a monolithic architecture where everything is depending on each other instead of modular or service architecture or microservices architecture and so on. Next model other than Spotify model I want to talk about is called Team Topologies by Matthew Skelton and Manuel Paes. So what is Team Topologies? Team Topology is a practical, strategic approach for structuring and evolving software delivery organizations. Matthew Skelton and Manuel Paes actually have been talking about some of the shortcomings of the Spotify model, and they tried to address it with their new theory, this new framework. This is originating from the book Team Topologies, Organizing Business and Technology Teams for Fast Flow, where the book provides a model for organizing teams in a way that optimizes communication and collaboration to enable a flow of value to the customer. So what they are trying to say is that there are 4 fundamental team types. Just like in the earlier one, Spotify model also has four team types, right? Tribe, chapter, guild, and squad. Here, it's stream-aligned teams, enabling teams, complicated subsystems teams, platform teams. And what they're saying that these 4 fundamental team types, these teams work with each other using 3 interaction modes. One is collaboration, that is like cross-team or cross-functional collaboration. Another is X as a service, like platform as a service, software as a service, container as a service, all those kind of X as a service. And another is facilitation, like helping one team helping the other team. Here is the diagram that tries to capture those 4 fundamental types and 3 team interaction modes. So the stream aligned teams here is nothing but product development teams. So I don't like these terms, the stream aligned teams, but the way they wanted to use is like stream of work or flow of work, one after another. They are actually delivering business values. So a lot of product engineering teams, in one sense, you can say those are stream aligned teams. That means in an organization, you'll have many stream aligned teams or many product teams like these product engineering teams. So that's one. So that's an easy one. We all understand. Some companies call them business application development team or application development team and so on. And then there is a second type called enabling team. Enabling teams are teams that are assembled together for a temporary period of time with a particular goal in mind. For example, let's say your software architecture is moving from monolith to microservices. Let's say you decided you'll use Amazon Web Services, AWS, and you decided you'll be using Kubernetes EKS. So you don't have any structure. So what you do, you hire a team of DevOps people who will be working, let's say, 3 months or 6 months, and build the Kubernetes cluster, the pods, to accommodate the engineers, the stream aligned team, so that they can move their current monolith, break it to microservices, and put those microservices one by one in different pods within that cluster. So this team, this enabling team, this DevOps team, will be taking this special project. You'll be forming them from many reliability engineering engineers within different teams, or maybe you already have a DevOps team and you take out a subset of them and create this temporary enabling team who will be just helping to build this. And once it is done and the other stream aligned teams or product teams are trained on it, you dismantle that enabling team. You don't need them anymore. Then you create another enabling team for, let's say you want to move from MySQL or a relational database to a NoSQL database system for storing all data in your organization, let's say DynamoDB. And that means you need a specially skilled database experts, SQL, NoSQL experts, performance optimization experts, and so on, who will come look at the schema and create new schema and show you a way how to migrate the data, maybe using DMS, database migration system of AWS, and so on. Again, you maybe assemble a 3 months or 6 months long team who does that for you, shows one module how to move, and then train it to the other product aligned team so that they can move the rest of the things, and you can dismantle them too. That is the enabling team. What is the complicated subsystem team? The complicated subsystem team is something like for which you need a very special knowledge. You cannot just have any engineer go and work on them. A particular type of engineers, and these are not straightforward works, like these are niche works. You need to build different type of teams for it, like stream aligned teams, like product engineering teams will not be able to do that. What are some examples? So let's say one example is your machine learning model teams or AI team. So it's pretty complicated, developing the models, training the models, validating the models, and so on. It needs the knowledge of statistics, data science, data engineering, ML ops, and so on. So your regular product development or platform team or other teams will not be able to work on it. So that can be one complicated subsystem team example. Maybe another example of a complicated subsystem team will be the team that develops your data lake end-to-end, like business intelligence. They generate insights out of it. Snowflake, Redshift, or other kind of technologies that allow building data lakes, not just your microservices, how you take your microservices database data and put it into the data lake, not only for reporting, but also business intelligence, insights, and so on, and backup, maintenance, and so on. So it's a pretty complicated one. Your regular product engineering team or stream aligned teams will not be able to do this. So every company has one or two complicated subsystems like this, maybe specializing on their particular domain, the business that they are doing, and so on. And then finally, platform team. So the platform teams are usually a type of enabling team who are not temporary. Basically, they allow these stream aligned teams to focus on just writing the business logic, the code, the functional part of it, and they take care of the tech stack, technical thing, how to access database, how to use, let's say, an event-driven architecture like Kafka and so on, or SQS and so on, message queuing, how you are going to use a framework. Let's say, should you use a Spring framework with JDBC, or you should use Hibernate and so on. So core platform teams will take care of those things. So a lot of companies have platform teams, and not only backend platform team, you may have mobile platform team, like core mobile team and so on. So these four are different type of teams. So which means you will see the highest number of teams you will see usually is stream aligned teams, a lot of product engineering teams, and some enabling team, complicated subsystem team, platform team, and so on. That's the idea of the team topologies, so that people can focus on their area of expertise and their domain. And the team interaction modes they are saying is that the facilitating means through the use of enabling team, you can do the facilitation, how teams interact. Similarly, collaboration definitely is one of the idea in this book the authors discussed, is that if you have to do too many cross-team collaborations, like you are crossing the team boundary, maybe there is some room for optimization in the team structure, because cross-team collaboration is expensive. Communication and collaboration should be, majority of this should be happening within the same team. That means if you see people are talking a lot, certain type of people, maybe they should be in the same team. The fact that they cross the team boundary maybe, and still they need a lot of collaboration constantly, points to maybe there is a problem in the team structure in the first place. Maybe those two teams should be one team, or some part of that team should be moved into this team, and so on, so that kind of thing. So these are very interesting model. Both works. So Spotify model you can take team topologies. Both of those have their advantages and disadvantages. So I would like to invite you to explore those and have your comment, like what's your experience? What other models you might have used? Are you using one of these two models? And so on. So apart from these, there are several other models that you can also explore. For example, let's say SAFe, a scale as agile framework. So right now is getting a lot of popularity. It's a Scrum, but it's a little bit more than Scrum. It not only just Scrum focuses on the software development part of the system, right, or the core part of it, how you different teams use Scrum to continuously deliver value to the business. SAFe works at a higher level. It takes those Scrum or Agile delivery processes, but it organizes it across the business. It takes care of business flow, something similar to Scrum of Scrums, where you have representative from each Scrum team, and Scrum of Scrum takes care of if all the whole organization is covered, all the business flow is covered. SAFe is a more matured and elaborate way of doing it, because it's not only just a Scrum of a Scrum, it takes care of many other things, including, let's say, release train or the TPM kind of responsibility, project management, program management, and so on. So it has a lot of recommendations on how to use different agile teams to deliver at a business level. So SAFe is one model. You can also use the Scrum of Scrums kind of models or some other models, but I feel like the three major contender for organizational structure or team structure when you're doing it will be mostly Spotify model, team topologies, or one of the Scrum of Scrums or SAFe scaled agile framework. One of these you might be able to use it. So I am particularly I have been using team topologies in my current company, and in my last company I have used the Spotify model. So I find both of those very interesting and very applicable. So that's what I wanted to discuss today. However, I'm interested to know, did you find this session useful? If you found it useful, please comment to this YouTube video, like it, and subscribe to my channel so that when I come with a new video, you get automatically notified. Also, let me know if you have a specific questions or concerns in the video comment, and I'll get back to you. Thank you, everyone, until I get back to you in my next video. Take care. Have a nice day.